Dortz, and this is the BSOD C++ tutorial on classes. There's a lot to cover, so I'm going to jump right into it. So, this is a makefile. Make is a Unix utility, and that basically will run shell commands for you. And it's really useful when you're developing programs and stuff because of these makefiles. It's going to let us lay out certain specific rules and dependency lists and everything that we are going to need to properly set up a program so that we don't have to recompile everything from scratch each time we do it. I mean, think if this were a major program, like 10,000 files, millions of lines of code. We do not want to have to recompile that every single time. This is where make comes in. It's going to detect which of the dependency files in each of these output files have been changed. Then only compile those output files and then relink the executable. I said a word that nobody understands yet. Linking. Now that's simply where the compiler is going to grab the precompiled bits of the program, these output files, and link them together. And it's going to build it into its single executable. You can do this outside of a makefile. You can do it however you want, really, but it's really ugly. And this presents things in a much more simple and concise manner, and frankly a lot easier this way than having to do it without make. So, two major types of lines: dependency lines and action lines. A dependency line contains two parts, a target and the target's dependencies. These are the source files. If any one of these files is changed, make goes ahead and rebuilds the target using the directions in the action line, which hold all the rules that were declared up here, and you can see the different syntax that it's used. We have rules and then any further options that we would need for it. Like, we have the options, and then we also, of course, include, like, for an output file, we have which compiler to use, the options to use with it, including -c, and main.cpp for main.o, which is this file that's actually going to be compiled by G++ in this case, because that's the compiler we're using. So, one more note for makefiles is clean here. This is generally included with all makefiles because, bugs happen. And say you find yourself in a makefile that it's gone and lost and cannot detect any changes in your files anymore. So you just go ahead and make clean, and it's going to delete all the files, and when the next time you remake it, it's going to build from scratch. So, let's head on over to apartment.h and get our first taste of classes. So, here we are with apartment.h, a header file, as opposed to .cpp, a CPP file. Generally, classes and everything are in header files, which is simply just the class declaration and a .cpp file of the same name over here, which this is all the implementation of the member functions. So, what is a class? A user-defined type. Now you can use them just as if they were going to be a regular variable, except they can do so much more. Like, I would have a group of, different variables, which I in fact do, and I can do almost anything with them using a class, depending on which functions and everything I have implemented. before jumping into syntax, these guys are preprocessor directives. Using these simply avoids double inclusion. Now, compilers are good at optimization as it is, but this prevents multiple copies of apartment.h from being compiled. Because each time you're going to do it, you're going to define a apartment h, I guess you'd call it an object, and it's going to check if it's already there. If it's not, it's going to skip all this up until the end if there. So it's good to just help keep things cleaner. So the actual syntax of how to declare a class is simply class, class name, open bracket, members of the class, close bracket, semicolon. So first thing we see in the class is public. This is a keyword, obviously. Now there are 3 different types of security levels in a class. It's public, protected, and private. Public is basically like the front end of the class, usable by everybody. Protected, which I didn't show because I don't need it, is usable by any derived subclass of our class. So, like, okay, if I had a board game class, and you want to make a subclass of a board game called chess, chess will be able to use any protected members that I have listed. So, listing members is just under each keyword. After that, there's public or private. So, first actual code here is a constructor. Now, constructors are declared without type because, well, that's the easiest way to equate them, is that it is a type. This is called when you create an apartment object, it's going to call one of these constructors. You can't overload constructors because here we have one that will set default values, and we're going to use this one specifically for creating pointers to an apartment object, because obviously we don't want to have to build in default values each time. We're just going to create a pointer to an already existing object. Here we have the second constructor, which is going to take default values. Now there are a couple other ones that we could implement here. A copy constructor and a destructor, which I have done in the other class I'm going to show you. So I will describe what they do later. But first, some standard member functions. Now, I don't remember if I ever covered it, but constant. That's all it means. So anything that it's going to, that is before the keyword, is not going to be changed. So here we have constant function. Nothing within the function is going to be changed. So this guarantees that I'm not doing anything except printing info here. Not doing anything except sending back a number here. Very important point, which I didn't actually make up here but should have, when dealing with strings, specifically when passing strings. A reference to a constant string needs to be used, because strings are dynamic just by definition. So therefore you can't screw with them. So they have to be passed as a constant. And now we have, those were all the public members. Most of them, I could put these there too, but that would entirely defeat the purpose of using it as a class. That would be using it as a struct. The difference between a struct and a class is you can define in a class the protections on certain things. What the user can use, what the user can mess with. If it was just a struct, I wouldn't be able to protect any of my values. So, again, no implementation here, So jumping over to apartment.cpp here, and we see we have our header file that is included here. That's going to just take all the class declaration, everything, and put it in here. A quick note on this. Remember the using namespace std we've always had. This tells the compiler that unless specified, scope to std. So std is just an all-encompassing any class that is covered by the STL, the standard template library. When you use your own class, you need to tell the compiler where these functions are implemented. That's called scoping. So again, why would I even bother? Why does this even exist? Because say you're a happy little user and you want to make a print info file. A print info function, I mean. So you're going to go in there, you'll just say, okay, print info and blah, blah, blah. But I've already got one in apartment. So if you include apartment, and there's a print info there, your print info is going to get confused with my print info. And it just wouldn't work. So therefore, I scope my print info to my apartment class using this scope operator, and you'll see how that works out in just a second right here. So our basic constructor, see how it is apartment scoped to apartment. So this is what is called when you declare a apartment object. Declaring an object is simply like declaring a variable. So all this is going to do is set it to default values. And this is what we would call, if we were going to dynamically allocate one, or create a pointer to one, this is what is set aside so that it knows, okay, we're going to head on over to there. We're going to point to an apartment object, so we know that we have to have a tenant and a number set aside, a string and a number set aside that we can use in the future should we need to. So this, however, has a second constructor, which is a bit more useful for regular usage, which takes a string and a number that will be just, instead of the default values of nothing and -1, it'll be those. Notice here, for each of these constructors, we haven't had to declare anything because they are already declared over an apartment age. They're declared in the class definition, therefore any members of the class can use them. So here's our 3 other member functions from earlier. I could go into detail, but I am not going to, mainly because I'm out of time, and I've still got another class to go over, which is far more interesting. So let's move on to building.h and show the full power of the big 3. Okay, and here is our second class, building, and the header file for it. Note we have everything basically set up the same way as apartment. We've also included apartment because it's an apartment building that we're making. So we have a couple of constructors here. The standard constructor, which is going to take an integer that's going to say just how many apartments are going to be in the building. But we also have a couple other things included. The copy constructor and the destructor. Together they make the big 3. If you have not implemented any one of these, the constructor will do this for you when you compile it. So I haven't done